But I also like using complete FRQ questions because they've been given before and they're going to be like similar in difficulty and everything to what they've given. So I might do it, even though honestly this part's the easiest part of this question. So if I do put it on here, I don't think you'll have any issues right here. So for part A, it gives a slope field for this differential equation and says to sketch the solution curves through the points 0, 1, and 0, 5 halves. So this right here is the point 0, 1. The solution curve that goes through it looks like this. It is that horizontal line because all of the slopes are all just line up in a line right there. You don't have to do all those little lines. Just draw you a little graph and draw these answers in. But definitely don't try to do all those slope field lines. It'll take forever. So if we want to draw the answer for our slope or our graph here, we would need to do something like this. It's got to kind of follow the curve of the lines. Now, you may decide that you want to go up higher right here or lower. The only thing is you just can't like go against the grain of the graph, right? Like I couldn't do, for example, I could not do a graph that did like this or something and start going across those lines, right? So you're just kind of following the flow of the graph. This is something I feel like I could kind of teach like Henry how to do because it's kind of intuitive what you're looking, you just want to follow that flow. This part maybe is a little bit tricky because you do have like positive slopes and then all these horizontal slopes and then negative slopes, so that's showing probably maximum somewhere there. And again, like if you, like let me do another one that would still be correct. Like if I drew in, if I went, maybe I did like this, but then over here I kind of went like this. That green graph would still be correct as well. You're just not going like across. I might be getting a little bit iffy right there. To me, this side's easier to draw, but this would still be correct. So you're just following that flow of the graph. I might put one on your test. You won't see it on the AP exam this year because they're not going to give you that copy of the graph. But they might ask you a multiple choice question about it, like which one of these could be the question there. I think it's probably the easiest part of this one, so if I were you guys, I would not be upset if I give you that type, even though you won't see it on the exam for that. All right, B says write an equation for the line tangent to the solution curve in part A at the point 0, 5, 2. So a tangent line is not solving a differential equation. When they give you a differential equation, it's usually the last part that's asking you to solve that differential equation. So here they're asking for a tangent line. They have already given us the point. The point is 0, 5 halves, so we do not have to do that part. I also need a slope for a tangent line. How do I find a slope? Very good. So your derivative, which is your differential equation here, gives you your slope. So we got dy dx such that xy equals 0, 5 halves, and that is going to be y. No, sorry, I got to plug in my numbers. No y will be there. 5 halves minus 1 times 0 plus 1 times cosine of 0 squared plus 2 times 0 plus pi. And technically, you don't have to simplify this, but it's going to be hard to write the equation of the tangent line when that is your slope, right? It's ugly. So I would actually simplify here. So 5 halves minus 1 is going to be 5 halves minus 2 over 2. That's going to give you 3 halves. 0 plus 1 is just 1. And then we got cosine of pi. And we know our unit circle so well. I feel like we might be a little rusty on it. We haven't used it in a while, have we? Pi's right here. Coordinates of that point are -1, 0. Cosine is that my x or my y? It's x. So I got 3 halves times 1 times -1. So I will get -3 halves for my slope. And so my tangent line is going to be y equals -3 halves times x minus 0 plus 5 halves. Of course, that minus 0 is not necessary, but you can put it there if you want. I just go with the formula, even if it's not the most simple. They like to ask tangent line problems on these types of questions. Expect to see one differential equation where it starts off with some sort of tangent line something, because usually, like, the main thing they want you to do is solve the differential equation, but they got to give you something worth some points in the beginning, and that stuff is usually old stuff that you're doing. It's usually not the differential equation that you're solving. Okay, but C for this one is going to ask you to solve the differential equation. It says find the particular solution, y equals f of x, to the differential equation with the initial condition f of 0 equals 5 halves. That y equals f of x is telling you your answer has to be solved for y. You can't just leave it in another form. So for this one's a scary problem to me. It's such a big differential equation. It's really not as terrible as it looks, but it looks awful because it's got trig, it's long. No, the x. Oh. There we go. That would make it way worse. Alright, so if I want to solve the differential equation, I have got to separate variables first. If you don't separate variables, you can't get any points on this, and let's see what it's worth. I bet it's worth 4 or 5. Part C is worth 6 points. So if you don't separate variables, you get 0. No matter what you do after this, you get 0 out of 6. So you want to make sure that you separate your variables correctly. And that's, usually they're not worth 6. Usually they're worth like 4 or 5. But still, this is a heavily weighted portion. What do I need to do to get that solved or separated? Multiply by dx is pretty much always our first move in most cases. So I got dy equals y minus 1, x plus 1, cosine of x squared plus 2x plus pi dx. Okay? And then divide by y minus 1. And so I got dy over y minus 1 equals x plus 1 cosine of x squared plus 2x plus pi dx. Alright, am I separated now? Yep, I got all x's on one side, all y's on the other. So I'm ready to integrate both sides. What happens here is both sides are actually a u to u substitution. Be careful with this. If you are doing a u to u substitution on both sides and you write it down, I can live with it if you don't write it down on the left side because it's a pretty easy u to u. The right side, you're going to probably need to write it down. Then don't use u's for both of them. Pick a different letter. So like if I use a u over here for this, u equals y minus 1, then du is just dy right here. So since I've already used a u, I don't want to use u again for a different part. So pick a different letter. It doesn't matter. Just don't use any of the other variables that are in the problem already. So, you know, like I'm going to use an a. It doesn't matter what letter you use. So if a is x squared plus 2x plus pi, what would we get for our dA? 2x plus 2 dx. A. So on the left-hand side, you can write this part or not write this part. It doesn't matter, but you've got du over u right here. On the right-hand side, you need to work on this a little bit because you've got your a. Do you have your dA part? You got a dx and you got an x plus 1. We're supposed to have 2x plus 2 dx. Good. And if I multiply by 2 here, then multiply by 1/2 out front. So I've got 1/2 integral of cosine A dA. Stop for a second, so make sure everybody's with me there. Okay, questions so far? All right. What do I get when I integrate du over u? Natural log of the absolute value of u. Are you guys all right if I go ahead and put that back in? That's my y minus 1. Okay, thank you, Joshua. Okay, and then over here, I'm going to have 1/2. What's the derivative, or what's the integral of cosine? It is sine of A, but is it okay with you guys if I go ahead and plug it back in so I have fewer steps that have to be shown here? And I have forgotten something very important. Plus C. Because, look over here at the scoring. You get a point for separating variables correctly. You get a point for your dy antiderivative, so that's this natural log of the absolute value of y minus 1. Then substitution is talking about doing the u du. I think they're giving you particularly credit on the right side for trying to do a u du over here. And then for getting the correct antiderivative right here. So we've already got 4 of these 6 points at this point. But the next one is for the constant of integration and uses initial condition. If you don't have your plus C here, you're not going to be able to get any more points. You'll be done for that. So you've got to have that C to be able to plug in for initial conditions. Okay, so we're good here. So the good thing about this is you have got most of the points here. We've got 4 of the 6 points because there's going to be kind of a lot of work for the last points on this. Do I want to plug in, what's the point, 0, 5/2? Oh, gosh. Okay, here's what I would suggest on this one. it's not particularly easy to find C or to solve for Y. But the fifth point right here is for the constant of integration, which means just putting the plus C there, and using the initial condition. So let me show you the only thing you have to do to get that next point. The only thing you have to do to get that next point is do natural log of 5/2 minus 1 equals 1/2 sine of 0 squared plus 2 times 0 plus pi plus C. Just plug in the point 0, 5/2. So you have used your initial condition and you have your plus C. So at this point, you have got 5 of the 6 points. I do not necessarily think it's easier to find the C first here, but even if I mess up after this point, no matter what I do, I've already got 5 of the 6 points, and I'm going to get 5 of the 6 points. Whereas if I solve for Y first, which is a little harder to do, and I mess it up, I might miss both of those last points. So I would do this here. So if we're solving for C, we got natural log of absolute value of 3/2 equals 1/2 sine of pi plus C. What is sine of pi? Is 0. Natural log absolute value of 3/2. Technically, those absolute value bars aren't really necessary because 3/2 is positive here. And half of 0 is still 0, so I get C. So my C is natural log of 3/2. So now my equation is natural log absolute value of Y minus 1 equals 1/2 sine of x squared plus 2x plus pi plus the natural log of the absolute value of 3/2, or absolute value. Okay, here. All right, last thing is we want to solve this for Y. So, especially on a free response question, their answer is going to be simplified much better than what we're given, but there is no rule about how you have to simplify this. You just have to get, you have to get the Y by itself. So I wouldn't try to simplify on this. How do I get rid of the natural log? E to the power. I'm going to show you some simplification here at the end just so you see how this matches what they give as the answer. But you don't have to do it. So I'm going to show you the way I would give the answer if I was taking the exam, and then I'll show you how it simplifies. Yep. So we've got E to all of this stuff here. Technically, there's some stuff that can simplify here, but I'm not messing with it because I just have to get the Y by itself. So I then need to subtract that 1, add that 1, so I get E to the 1/2 sine of x squared plus 2x plus pi plus the natural log of 3/2. And then make sure your plus 1 is down here, not in the exponent.
Will we actually need to do all this?
To get full points, this is what you would have to have, yeah. But we were already way back up here. We already got 5 out of the 6 points right here. So if you fall apart or if you're running out of time, just stop, because that solving for Y here is only getting us 1 more point here. And that generally is going to be the case on all these. So if you're running out of time or if you're falling apart and it's not going well, make sure you got your plus C, plug in your initial condition, quit and move on to the next thing. Because it's just a point for that solving for Y part. This is the way I would leave it if I were doing this problem. I would stop here. They do not. They give the answer as y equals 1 plus 3 halves e to the 1/2 sine of x squared plus 2x plus pi. So what they have done there, which is not necessary for you to do, but I'll run through it in case you were to see this on like a multiple choice situation where you having to match this up, is when you do this, this part right here was like your C, right? So what you really had is you had e to the 1/2 sine of x squared plus 2x plus pi times e to the natural log of 3/2. And e and natural log cancel each other out. And so you would just have 3/2 times e to the 1/2 sine of x squared. Plus 2x plus pi. And then they put the 1 up front instead of putting it at the end. So, again, I wouldn't do it. But it does help you see like how your answer, when you're looking at the answer on AP Classroom, you're going to see this is the answer. This is how you get from here to here, but you could leave it at that point. Okay. Questions? Again, if I were running short on time, I wouldn't solve for y. On any of these, I would wait till the end to solve for y, because it's only a point, and you get, usually they're not worth 6, usually it's 4 or 5, but you'll get the majority of the points before you solve for y. Okay, I'm gonna let you guys, well, yeah. Let me look through the multiple choice real quick and just remind you a couple things about ones that we did back before the midterm, because we didn't do much. We just did slope fields and a couple little things here before the midterm. But let me remind you of a couple things here. Example number 2 in the multiple choice. The rate of change of the volume with respect to time of water leaking from a tank is proportional to the cube of the volume. Which of the following differential equation that could describe this relationship? So that one's just asking you to read and interpret, right? So like rate of change of the volume with respect to time. That's dV dt. All the answer choices have that, right? Is proportional to. That's where you do equals k. They've put a number for all the k's, so we might have a number there instead. Proportional to the cube of the volume. Well, both of these, B and D, have the cube of the volume there. Which of the following is a differential equation? How would I choose between B and D? Water's leaking out. You want to choose B because it's negative. So you would have that inverse relationship. So B would be the answer on that one. So there's some of that. Those should be quicker problems because you're not actually solving them. That one's similar. Similar. Okay, let's look at 5. It says which 5 can be solved. Let's look at 6. 6 you can't solve that. It's 4y equals y double prime, or 4y plus y double prime equals 0. You don't know how to solve that as a differential equation. Technically, you could solve this one, although I would do it like I'm getting ready to do number 6 here. So what you're looking for is an answer that makes that equation true. So if I look at 1 first, we did these long ago. Y is 3 sine of 2x. Now, I don't need y prime, but I've got to find it to be able to find y double prime. When I take the derivative of sine, I get cosine. So I've got 3 cosine of 2x. But then I've got to multiply that by 2 for a chain rule. So I'll get 6 cosine of 2x. There's my first derivative. My second derivative is derivative of cosine is negative sine. So I'll get negative 6 sine of 2x. That also has to be multiplied by 2. So that's going to be negative 12 sine of 2x. So what you're wanting to see is if it makes that differential equation true. So if I do 4y plus y double prime equals 0, for 1, I would do 4 times 3 sine 2x plus y double prime, which is negative 12 sine of 2x. And that is supposed to equal 0. And you can see here we're getting 12 sine 2x minus 12 sine 2x. That is, in fact, going to equal 0. So 1 is an answer. Do I even need to check 2? If you look at your answer choices. 1 is definitely an answer. 2 I need to check. Do I need to check 3? I don't need to check 3 because there's no 1 in 3, right? So I don't really have to check 3, but I do have to check 2. So you do the same thing over with 2 and see which one works for you there. So I know it's been, like, we just did that a few problems and it was a long time ago, so I figured we probably forgot that. So like 5, 6, and 7 can all be done that way. Slope fields, you're most likely to see your slope field problems in multiple choice form now because you can't draw them in there. So you'll have a few slope fields, and then when you get to 11, it starts to get to ones where you're actually solving the differential equations. So you really won't do much solving differential equations until you get over to 11. I think 1 might be one where you actually solve it as well. But most of those in the middle aren't. Okay. So I'm going to let you work. You can work with whoever you would like. I'll be around to help as you work on it.